Ladies and gentlemen, good afternoon. My name is George Thanos and I am the president of CSEO. Today, we have the third episode in our series, SpaceWorks 2030. And we are honored to have with us Dr. Marcello Coradini, who was the head of solar system exploration for the European Space Agency for a number of decades. He led a number of missions like Rosetta and many other missions like Solar Orbiter. So we will have him with us today to explain how solar system exploration in the future will be, but on top of that, he will guide us in a very interesting journey as to how humanity might develop through evolution when we go out to other solar systems and different environments. So, without further ado, let me welcome Dr. Coradini to our today's episode.
Thank you, George, for your presentation. I'm very glad to be with you and with the listeners, and I'll try to explain through a beautiful voyage into the deep space the adventure of human exploration outside the solar system. I think that we are getting very familiar with all the planets which revolve around the sun, and it's time to think about galactic exploration. Maybe it's a bit daring, but we have to throw our heart on the other side of the obstacle. The obstacle is distance, is time, is patience, is endurance of the astronauts. But let's pretend for a minute that we have discovered a starship capable of taking us beyond the solar system. Will the human beings on board this spaceship will remain the same? We're talking about travels, even if we cruise at the speed of light, which is 300,000 kilometers per second, compared to the infinity, even of our galaxy. It means that even at the speed of light, we are moving very slowly, and the journey will take a long time. So what's going to happen to the crew of astronauts on these big space starts or starship when it's going for years and years and years, and we will have generations of astronauts? So we have to think out of the box. It's no longer a tiny little space capsule. This is almost a traveling column. But the conditions during this galactic journey will be very harsh and very different for the human body. We have seen science fiction movies, particularly Space Odyssey 2001, for those who are old enough to remember this movie, that all the solutions were already there. We can create artificial gravity, we can entertain and train the astronauts, we can almost recreate a terrestrial cradle in space. But at the moment, this journey will come to a destination. The goal is not traveling, the goal is reaching a target. So which kind of target can we reach? Well, obviously, we want to go where there is a hint or a possibility of adapting ourselves to the external conditions. So we want to get out of our spaceship and we want to settle on the surface of the planet. But before doing that, we have to ask ourselves what happened to us and why we are the way we are on our planet. Well, our planet is very simply a body which is full of liquid water. It has a lot of energy or energy sources, volcanoes, lightnings, and many other. And we have a carbon source. Carbon is essential for development of life. And life is pretty resilient. It can adapt from hundreds to hundreds degrees Celsius, at least the life that we know. It can be in very acidic environment. It can survive extremely high pressures. So life, the way we know it, from the simplest forms, from viruses to human beings, are very resilient, but at a price. The issue is that this price is adapting to the external conditions. So when we start our galactic journey, we should ask ourselves where we're going. Well, we want to go towards a so-called habitable planet. But what is the definition of habitable planet? So it's a planet with liquid water, a planet with potential energy sources, solar, geochemical, or hydrothermal, a planet that has carbon, a planet that is geologically active. And why do we need geological activity, or geological life, if you prefer? Because this guarantees renewal of nutrients and renewal and sustainment to the energy sources. And on top of that, this planet has to protect us, or the local inhabitants, from the harsh interplanetary environment. So we need basically a strong magnetic field. So the question is, how many places there are like the Earth that fulfills all these conditions? Well, I must say, not many. Even within the solar system, the habitability zone is very, very narrow. Today, as you can see, we go from 0, which is the distance, which is where the sun is, and we move away from the sun, moving to the right of this image. We see that the habitable zone, as we define it, or as we have already defined it, it's very, very narrow. Maybe in the past there was something slighter, because maybe Venus was a kind of colder, or maybe Mars was a kind of warmer, but even in the solar system, the habitable zone is very, very small. So that restricts our search. What is important is to understand what are the parameters which determine the human morphology, why we are the way we are, with one head, two arms, two hands with opposable thumb, two legs, and so on. Well, our body has been built over millions and millions of years, adapting to gravity, to the composition of the atmosphere of the Earth, to the atmospheric pressure of more or less 1 atmosphere, or 1,000 millibar, roughly speaking. We developed inside a magnetic field which determines the amount of radiation we can withstand. Most of the radiation is screened by the terrestrial magnetic field. That's why we are around. And then the temperature. It's true that human beings and life on Earth can survive from -50 to probably +80. But however, the temperature is a major parameter because it determines how we cool off or warm ourselves. Some animals develop a fur. The human beings have lost their fur, but if we go in a place which is much colder, do we need a fur again? Are we going to become just like a monkey again? Well, that's a question that we should ask ourselves, because these parameters all together determine the overall morphology of the human body, the shape and size of our eyes, the shape of our nose, the functioning of an inner ear, and the external shape of the ear. It determines how tall we are, how wide we are, how big our bones are, and so on and so on. And also, how thick is our skin. Oh, you can say that in today's political environment, we need a thick skin. But imagine if you are exposed to very high radiation, you need even a thicker skin. So, as of today, we know about 55 habitable planets, and they are a kind of harsh sometimes. So we know one which is smaller than the Earth, more or less the size of Mars, about 20 which have the size of the Earth, and 34 which are bigger. Which means being bigger, it means that the gravity is much higher, which means being smaller, it means that the gravity is much smaller. So imagine Probably many of you have seen the astronauts coming back from a long orbital space adventure. So what happens to the body of these astronauts? They have water retention, they start losing calcium in their bones, the total mass of their muscles decrease, despite the fact that they train all the time. To the point that when they come back after 1 year mission, they can't walk and they need to be hospitalized and readapted to the gravity of the Earth. So that puts you into the direction of what would happen to a body if we spend millions and millions of years, generations after generation, in a planet which is bigger or in a planet which is smaller than the Earth. Automatically, the human body would adapt to the local conditions. When we place this candidate for galactic exploration in a graph that shows the habitable zone, we can have an optimistic estimate or a more conservative habitable zone. But if we take a conservative approach, the candidates to go and to reach with our spaceship are not very many. And consequently, more than choosing the right planet, this crew of astronauts, which has been sent into the depth of space, will have to adapt itself to the planet they find, and not the other way around. But even on Earth, when we show the variability of the human body, you see in this image, it's a midget, it's a giant, and in between you have all possible shapes and sizes for the human being. On the left-hand side, you see the spread of the physical characteristic, height and mass of men and women, and they have pretty large spread, even if we all live in the same environment. So imagine if we take such a variable body and we put it in an environment which is dramatically different than the environment of the Earth. The differences that we see today between the midget and the giant will become the norm. And what will be, then the question is, the normal or the average human being? Well, what happens is that there are immediate evolution. The body size is not controlled by just one gene, but by many, making it hard to predict the size of individuals before they reach adulthood. So these differences may range in body size that develop in the first place. Can we look at random genetic mutations? Can we have competitive leading and environmental influences? Well, we have seen the evolution of the Homo sapiens up to what the human being is today. And a few tens of thousands of years ago, we were looking pretty different than today. So that means that the human body is designed genetically to evolve, and not necessarily always in the same direction. So let's play with some changes in gravity, pressure, and radiation environment. Let's imagine, for instance, that we find a planet which is bigger than the Earth, and so the gravity will be 2 to 3 times higher than the gravity on our planet. And because the gravity is much bigger, probably the atmosphere around this planet will be thicker because it traps the molecule of the atmosphere much more easily. And we may assume that we have the same radiation environment, so more or less the same magnetic field that we have here on Earth. As you can see, the human body would immediately adapt. First of all, in order to breathe in a much higher pressure environment, our lungs would become much bigger. And the heart would become extremely bigger and much more powerful to pump blood and win the attraction towards your feet of a very strong gravity. So the end result is that the intestines will collapse towards your legs and the chest will expand immediately. Obviously, because of the gravity, the spine will collapse, the backbone will collapse. So the human being in this planet will immediately look like a person which is no more than 3 to 3.5 feet, or let's say about 1 meter, 1.2, 1.3 meters, if you are a big giant in this planet, high, but it would be very, very wide. And the internal organs would be extremely powerful to win the gravity and to deal with a very high density of the atmosphere. And obviously, all these changes, in order to withstand, we would develop the gravity, we would develop a much stronger bone system. So this midget, which is more or less 1 meter or 3.5 feet of height, it would weigh basically 150 or 200 kilograms. It's huge. It's a huge variation just by change the gravity a little bit. On our planet, we know that every, I would say, ethnos can be recognized by the shape of their nose. So we have the Greek nose, which is aligned with the forehead, the Dinarid, the Roman, the Armenic, the Arabic, the Jewish. There's a large variety. And we are accustomed to recognize the origin of a person by looking at their face, but unconsciously, what we do, we are looking at the nose of the people that characterize our expression. So there's a rule that was developed by a British scientist in the 1800s, Arthur Thompson, a British anatomist and anthropologist, that pointed out that long, thin noses tended to occur in colder, drier regions, whereas shorter, wider nose more often appear in hotter, more humid areas. This rule is now referred to as the Thompson nose rule. So let's try to play with this rule. So the theory is that narrower nostrils alter the airflow in such a way that the mucus-covered nasal membrane can warm and humidify incoming air more efficiently. This would help individuals with narrower noses to survive better in colder climates, and therefore be more likely to reproduce. Over time, this would have slowly driven nose size down. The other way around, if we live in a very warm environment, we would have exactly the opposite process, and the nose will enlarge to inject much more air. In other words, the nose, it's one of the characteristics of the human body that immediately adapts to small variation, even in humidity of the atmosphere, and even more to atmospheric pressure. So in the planets that we have seen before, where the atmospheric pressure is much higher, the morphology, the shape of the nose, will change immediately. Then there is another major characteristic of the human face, the eyes. We say that the eyes are the mirror of the soul. We recognize the goodness or the badness of a human being by looking at his or her eyes. Well, astronauts will have completely different parameters or judgmental parameters, because already now geneticists have ascertained that intensive use of computers and screens will affect the size of human eye. A space civilization, basically during the long trip, would strongly rely on augmented and virtual reality and massive use of computer technology. Consequently, the human eye will most likely follow this enlarging pattern. But if we enlarge the size of the eye, can we contain in the same size of head a much bigger eye? The answer is no, because otherwise the eye would push against the brain and we would have brain damage. Consequently, if we enlarge the size of our eyes, automatically we have to enlarge the size of our head. So having a big and shiny head, like mine, may be then very well the standard of beauty in about 50,000 years from now. And it goes without saying that hair and hairs, more and more we're losing them because we don't need to protect ourselves with natural protection. We have clothing, we have scaphanders, we have spacesuits. And so the human body will lose completely all the hairness. And honestly speaking, when we see in science fiction movies the aliens that look like this image, well, I must say that in this instance, the science fiction movie are not far from a reality of the Homo superior, if you like, the human being in 50,000 years from now. Another process that determines the shape and the performance of the eye is the radiation that the eye can detect. We talk about visual radiation. We see things, but these are very specific wavelengths. Now, let's imagine, and in the image there, it's the same object, but observed at different wavelength. If we look at radio wave or infrared radiation or visible light, ultraviolet, low energy X-ray or high energy X-ray, we see completely different things because every wavelength corresponds to a physical process. So when we say we see something, we're looking at the visible radiation that is emitted by a body. But if we go in a planet where maybe the magnetic field is slightly less intense than the magnetic field on Earth, the human eye would be invested by a completely different radiation. So the human eye will adapt and will detect, just like the detector on a telescope, different wavelengths. So the human eye will look completely different, but not only the human eye will look completely different, the perception of reality that we have will be different. So imagine that these images are the images of a very common object. So if we look at this object with visible light, for instance, a bottle, we would see the bottle. But if we look with X-ray at the bottle, probably we would see the composition of the content of the bottle. So imagine a reality where I don't see the shape of your body, but I can see the energy produced by your intestine or the infrared radiation emitted by your brain. It will be a completely different approach to communication and to appreciation of the reality around us. And nevertheless, this would still be a human being. It's simply a human being that has different eyes and a different perception of reality. But even more, if we increase the amount of radiation, our skin will react. It will become, first of all, darker and then thicker. So, when, again, in science fiction, they depict the aliens as looking like lizards, well, again, that could be a human being. We could take a sample of the skin or the body of that space lizard, and we would realize that it has DNA of a human being. Oh my God, but then we are all the same. When we look at the DNA, there is no color of the skin, there is no thickness of the skin, there is no beauty or ugliness. We are all human beings, even if we look completely different. So maybe we could have a big help through space exploration and adaptation and space colonization to the elimination of races, because everyone will look different and adapted to different reality. It's like in Star Wars, where many different species who look completely different, nevertheless, interact peacefully among themselves. I really hope that this would be a positive trend. But if we are pessimists, then the races will be not only between white or red or black or yellow skin. It will be the skin of a lizard or the burn aspect with a very thick skin of this human being that comes back from the stars. The food and the feed will follow exactly the same evolutive process. And all depends on how much we walk and in which kind of gravity we walk. Even today, we have seen more and more the birth of children which have one toe less or even two toe less. And this will determine not only the shape, but the way we walk. And the way we walk, if we push to the extreme consequences, if we walk in a very low gravity, we don't need the toes anymore because we don't need to counterbalance our foot and our body while we're walking. So maybe we would end up with a foot that has just one toe, or it's that the whole foot is a toe. But that would influence as well all the joints. I mean, living in a different gravity environment, pressure, would determine how the joints of the human body will work. And I wouldn't be surprised if you are in a very high density planet with a strong gravity, that your joints will be completely different than if you are in a low gravity environment. So maybe we tend to resemble more to jellyfishes in a low gravity, or we look like more orangutans or monkeys if we live in a high gravity environment. The same evolution will take place to our ear. The ear is a rudimental instrument that transforms vibrations of pressure into sound. Fine, but if we change the pressure, we'll change the frequency. And so the human ear, the way it is today, already you can make an experiment. Try to listen to someone speaking to you underwater. Can you understand what he or she says? No, because the voice and the sound of our voice underwater is transmitted in a completely different way. So imagine that we are in a planet that has an atmosphere like that of Venus, which is 100 times thicker than the atmosphere of the Earth. Well, our ear will have to evolve in order to be able to capture and to perceive frequencies that today we would not be capable to detect. So also the inner ear and the external ear will evolve as a function of the environment. And it goes without saying that the human ear will change. And most likely, if we are in a very dense planet, our way of walking will resemble much more that of a kangaroo than that of a human being. So imagine this human body where you jump instead of walking, where you have gigantic ears or almost non-existing ears. You have eyes that are looking at reality through X-ray or infrared radiation, so they look at the inner body and not the outer shell of your body. Oh my God, and maybe they have the skin of a lizard. We would say, oh my God, this is a monster, this is an alien that comes to kill us. No, that's a human being. It has the same DNA. It is simply a human being that has adapted to a completely different environment. So in other words, in the universe there are 10 to the 11 or 10 to 12 galaxies, which means 10 followed by 11 zeros or 12 zeros. It's a huge number, thousands of billions. There will be many, many planets where we can go. And if we go to those planets and we'll adapt to live in those planets, we will become the real aliens. In other words, the aliens will be us. Thank you.
Marcello, thank you very much for this wonderful presentation. So when we go out there and we meet other aliens and come back to our home, maybe we won't be recognized by the people who we left behind, that we are their own species.
That's very likely. Even the twin paradox, that was created by Einstein. If you send two twins and one stay on the Earth and the other one start traveling at the speed of light, they will age in a different way. So they're twins, but one is old and the other one is young. So that's the simplest way of changing the human body, of the same human body. So imagine that on top of traveling at the speed of light, you have all this environmental variation. It will be a real catastrophic, I would say, or nuclear change of our body.
There are lots of interesting movies set in the far, far future that show cases like that. So I would even say, is it possible that some alien species that has developed greatly, that came and colonized our planet a long time ago, and we are actually from a different planet having developed elsewhere?
Absolutely. We don't know. We have no proof of that. It's a working hypothesis. But the other issue is that for sure, if one day we will meet some other civilization, for sure it will not look like us, because a tiny variation, as I said, of fundamental parameters will make completely different beings. And even if they are by matrix, still human beings will look completely different. That's why we should not be afraid of difference, because Mother Nature creates differences and nothing else.
And there's this notion that some scientists say that we have to be very, very afraid of alien civilizations, and they give the example of humanity stepping on an ant colony and they don't care about the consequences to the ant colony, or the behavior of humans when we went into other continents and the destruction that we caused. This is one theory, but the other theory is, why would an alien want to get out of its way to destroy a civilization which is so much less advanced as them? What is your view on these two different theories?
Well, I actually support both views. If I take a human approach, I would be very pessimistic, simply because the human beings are not nice anymore. Actually, we're very nasty. We make wars, we kill people without any apparent reasons. We commit genocides. In the history of humankind, genocide has happened, unfortunately, many, many times. And the human beings on this planet, on our planet, have demonstrated that when two civilizations clash, obviously the more evolved civilization tends to annihilate the other civilization. So if we take this approach, we can be very afraid, because if somebody with a higher intelligence, higher technology than us, would behave like a human being, that's the end for us. My hope instead is that because they evolved much more than us, they have become even better than us in terms of respect and understanding of the differences. And maybe they will look at us and they realize that we're not really monkeys, that a little bit of intelligence we do have, and we'll try to communicate, and maybe they will train us and they will allow us to evolve.
And can I ask you, what is the likelihood that there is life, even bacterial life, on planets in our solar system, never mind planets that are far, far away? Say, recently there was this announcement of certain gases in the atmosphere of Venus, and then we heard that a team, and I believe that you were part of that team, on Mars have discovered underwater lakes. And then we know that Europa and other satellites of both Jupiter and Saturn most likely have got warm seas under the layer of ice. So what is your opinion? Could there be life already there on the other planets of our solar system?
Well, you might have noticed that at the beginning of my talk, I said that life is extremely resilient. It can survive from minus 100 to plus 100. It may survive at incredible pressure. It may survive radiations and so on and so on, acidic compounds. So some of the conditions that we find in other planets than the Earth in the solar system are milder that some places on this planet, on Earth, like the acidic lake that I showed in my first life, which is located in Spain, by the way, Rio Tinto, and where the conditions are much harsher than on Mars. So if life proliferates in such a bad environment, ugly, terrible environment on Earth, why not on Mars, which is just a little bit colder? The issue is being able to go to the places where life might have hidden itself. If you ask me, is there life on the surface of Mars? I will tell you no. Mars' surface is totally sterilized. But if we go underground, I am very positive that we can find something. And the same applies to Venus or maybe to Europe. So I'm a kind of positive. It's only a matter of developing the technology and using it for the good cause.
And your presentation today is a perfect introduction to the next two presentations we have. One from Karen McBride, who will talk to us about the likelihood of sending humans to Mars and how soon that is possible to happen. And then the next presentation after that from John Rummel from the SETI Institute on whether there is the possibility of detecting life in other solar systems far beyond our own.
I can't wait to listen to their presentations.
So can I go for one more question? What do you think life could possibly look like on planets like Jupiter that don't have a rigid surface and they're just full of gases? What do you think?
I don't think we can find life on gaseous planets. The life is, I have defined it in this presentation, and more or less as we define it, need a surface to walk around or water to swim around. On a gaseous compound, I don't think we can develop life because you don't have enough thermodynamical stability, which is one of the key parameters for the development of life. It's not how harsh is the environment, but how stable is the environment. If you keep changing environment, even mild variation on Earth, you may destroy life. So even on our planet, life started developing when the conditions became stable. So on a gaseous planet, you have turbulence, continuous movements of the gas, so you don't have a body where life can develop.
Okay, so those images we sometimes see that you have giant squids or beings hovering like balloons in the atmosphere of Jupiter. Those are very extreme cases and unlikely to actually occur.
Or maybe it was Pioneer mission that was photographed by another spacecraft. It wasn't man-made feature.
So, Marcello, you were the father of the Rosetta mission that went there and looked for the different type of water that exists on Rosetta and asked questions such as, is the water on comets same to the water we find on Earth, but also looked for organic molecules. What did we learn regarding life and or maybe the origin of life on Earth by studying the comet that Rosetta touched down to?
Well, there's a lot of theories speaking about that most of the water didn't get produced inside the Earth, but came from a comet bombardment. There are, without entering into complicated geochemical or physical discussions, there are differences between the waters that we find in space and the waters we find on the Earth. And we may trace back. So there are commonalities, but there are also differences. What is certain is the comets are the building block of the solar system. Without the comets, planets would not exist. And so they are a carrier. They kind of a messenger of the gods. If there is anything to be transported and distributed all over the solar system, that can happen only thanks to the comets. So by studying comets, we see how not only water, but deuterium, hydrogen, and other compounds, carbon, have been distributed and mixed up in different planets. So really studying comets, it's a kind of doing archaeology of the solar system. You go back billions of years and you see how the solar system looked like 4.5 billion years ago.
You had missions that went from studying the sun, Bepi Colombo, going to Mercury, possibly even Venus, Mars, and beyond. What would be your next choice of a mission, going to which destination within or even outside our solar system? What's your next goal?
Well, what I would do, and not necessarily is going to happen, I would try to land again on the surface of Titan, which is a fascinating place, and move around and try to better understand the inverse reality there, because it looks like the Earth, but everything is different. Or if I am allowed to have two dreams instead of one, the other dream, I would love to have a submarine in the depth of Europa. And maybe we can see life there passing in front of our windows, you know, that would be my dream.
Indeed, I would completely agree with both destinations. This would be also my dreams, because Europa has got a thick layer of ice, but underneath that layer of ice, there's probably 3 times the amount of water you have in all the seas and all the oceans of planet Earth. And we believe that it's got warm water, and with all the volcanic elements coming from the core of the satellite Europa, all those molecules, God knows what kind of life has emerged from that. And then you have on the other hand,
paradise for a biochemical person, you know.
Indeed. And then you have on the other hand Titan, where the mountains, the hard rock of the mountains is made from water, and the rivers is made from what would have been on Earth, gas, methane, and it's water there, and it's flowing as methane. Yes. And I distinctly remember that a brilliant team from Italy, from the Padova University, were the ones who were behind the lander that actually touched the surface of Titan and sent the first ever photographs from the surface of a satellite other than our own, the moon.
That's right. Yes, that was the experiment HASI, and also measured the first composition of the ground. And it's beautiful because, you know, it doesn't happen every day to discover a new work. And I was so fortunate in my life to see a new discovery of America, which is the discovery of Titan. So I am a very lucky person.
And you had an involvement in that scientific mission?
I also had an involvement in the experiment. Yes, indeed. Yeah.
And how about sending a mission outside our solar system? Do you see that as possible and feasible? There are some people who say that let's go even beyond the Voyagers and go into the nearest star, Proxima Centauri. Is that likely? And if it is likely, how would we achieve something like that?
Well, you know, it is feasible. It is indeed feasible. It's all about having nuclear generations of power, which has been forbidden for a long time because of not valid ecological arguments. I'm totally in favor of ecology of the Earth, but you know, when you see the amount of radiation that comes from the sun every day, even if you explode in the high atmosphere 10 atomic bombs, it would be a tiny little fraction of that radiation. So certainly with a spacecraft, we are not going to destroy our planet in case of an accident. This being said, the name of the game for any kind of deep space, very deep space, or intergalactic exploration is having enough energy. If we have energy, we can go anywhere. We can transport very large antennas that can communicate from incredible distances. It's all about energy and nothing else. All the rest we already master. All the other technology we already master.
And to go to Mars, for example, it takes approximately 6 months, depending on when you launch and when you reach Mars. If Mars is at its closest, 6 months is approximately the estimated journey time. But are there any new technologies that we can expect that are feasible in the next decades that can take us to Mars in a faster way so that it's possible to transfer humans onto that planet?
Absolutely. And again, it comes to energy. Maybe not everyone knows that when you launch a space mission, basically it's, I can depict it like this. You are at a traffic light, it's the day of your launch, okay? The green comes and you give a big acceleration to your car, and then you put it in neutral and you go downhill. In space, it's exactly like that. The launcher is speeding up first gear, second gear, and then you put in neutral and you go downhill. Because once you are out of the gravity of the Earth, we don't use motors anymore. We only use motors when we are at destination, just to slow down or to correct our orbit. But the big trajectory, the big cruise, is done in neutral. So it's not a very efficient way of traveling. And why we do that? Because we don't have enough energy to power and to ignite an engine. So again, if we could have a small and powerful energy source, we could operate very powerful ion or plasma drives, and we could shorten to 1 month, even to 1 week, the travel from the Earth to Mars. It's all about energy once again.
And therefore saying that, let's go on holidays. One day we might choose to go on holidays to Valles Marineris instead of Hawaii.
You know, it would be fantastic. Imagine the sunset on Mars are gorgeous and very romantic.
So would you think that sending humans to Mars should not be launched from Earth, but should be launched from a stepping stone such as the moon to go further onto there?
Look, from a dynamical point of view, what is really difficult is getting out of the gravity of the Earth. Once you are out of the gravity of the Earth, 80% of the job is done. So why should I go to the moon, where I need more propellant to slow down, and then I need more propellant to take off again? It's a waste of energy. A big lesson from the space station is, and the biggest lesson of this construction of the space station is, we have demonstrated that we can assemble gigantic infrastructure in orbit. To do that, the simple commercial launcher, if you buy a batch of them, say 1,000 Ariane 5 or 1,000 Falcons, the second 500 launcher will cost you almost nothing. And you can assemble much, much bigger structure than the space station. And then you start off from Earth orbit. That's the way to go. You know, since the origin of space exploration, there is a dichotomy in the mission scenario between the Korolev, who wanted to assemble stuff around the Earth, and von Braun, Korolev Russian, and von Braun, American, German-American, who wanted to build big launchers because that was his core business all of his life. And because von Braun was in the richest of the two countries, that scenario is still dominating. But not necessarily is the most intelligent one. I think that Korolev has always been my hero. He was the most intelligent space engineer ever. And I still support what he said.
And I remember I've been to the museum, the Korolev Museum in Moscow, and it's just outside of Moscow. It's absolutely amazing, the amount of exhibits that they have there, and his vision of solar system exploration. It's mind-boggling. There's a lot of buzz these days about the return and settling on the moon. What are the dangers and what are the precautions we have to take in actually creating such a settlement on the moon? And I'm thinking, firstly, our neighboring star, the sun. what's the effect of our star and cosmic radiation to and meteorites on settling on the moon?
Look, being on the surface of the moon is as dangerous as being in deep space. You have no protection at all. The only positive thing is that you have an up and down and a surface when you can walk very easily. Otherwise, it's like being an extravehicular activity all the time. Because there is no atmosphere, there is no magnetic field, you are at the same distance from the sun of the Earth, and you get all the damn radiation that comes from the sun directly on your head, on your skin, on your spacesuit. So you can't walk very easily on the surface of the moon unless you build an infrastructure that protects you there. It is not that difficult. There are natural tunnels there, lava tubes. Sometimes they are gigantic. You don't have to build building. You just go in there, you spend your time there, you protect yourself, and then you have extravehicular activity when you come out of these lava tubes, of these shelters. So the time that you can spend on the surface of the moon without protection is limited, but you can spend a long time if you have shelters. And because going to the moon is not for Superman, the trip is only 3 days with today's technology. The launchers are very mild in these days. I think that space tourism would boost very much the creation of a new space business. I think you can find thousands of people on this planet who would pay a fortune to go walking on the moon, and that would create a new market.
Why do we explore space? Do we explore because we want to learn? Do we explore because we want to bring back to our planet knowledge to protect our planet? Or do we explore simply because we have to carry on moving on from the area of the Mediterranean, colonizing the rest of the planet, having now to move the next step of humanity on and on? What is your view? And is there an extra reason other than the ones that I mentioned here?
You know, I believe that it's in our genes. We can give it a lot of noble varnish by saying, oh, the discovery, or the understanding. Whatever you want of noble, you can attach it to the exploration. But the real reason why we explore is because we cannot stay still. Human beings moved from Africa to the Mediterranean, and from the Mediterranean they went to Siberia. From Siberia they crossed the Bering Strait, and they went to Canada, and then they went through all North America and South America. They didn't have a why. They just wanted to see what's behind that hill, what's behind that hill, what's behind that hill. And once you find a new hill, you want to go and see what's behind it. So you go to a planet, and then what's in the other planet? What is the other planet? What's in the other planet? It's genetic. That's the only reason. We cannot stay still. If we stay in the cradle, it's like a baby who doesn't learn how to walk. It's half of a man, you know.
And I remember distinctly that photograph of a baby who just gets on its 4 feet, or like hands and feet, and it's just looking around, all ready to explore the next corner around the house or around the garden.
So what is the motivation of the child for moving around? Nothing else than discovery. We want to discover, because we're curious at genetic level.
Yes, it's in the genes, indeed.
Yeah.
Marcello, you've done so much from the 80s onward in solar system exploration, and many people consider you as the father of solar system exploration, at least for Europe. But with all these missions, you're the father of so many different missions. Is there a story? Is there a favorite project or activity or a memory you want to share with us? Something that stands out from all these years of achievements?
Well, I tell you moving stories, or stories of great successes, or stories of great disgraces, etc. Instead, I want to tell you something very fun. So we are at Cape Canaveral, and it's 2 days before the launch of the Cassini mission containing the Titan probe. And so we have to do the purge, the final cleaning of the Titan probe. And there it goes, the clash between two cultures. We write instructions with the metric system. The Americans engineer believe that instead of being kilograms per square meter, they were pounds per square inch. And so when we give them all the parameters to purge the Titan probe, what happens is that they pump so much air, nitrogen, that they destroy completely the miler. So 24 hours before the launch, basically, we're facing cancellation of the mission, one of the most brilliant missions in the history of space exploration. How did we rescue that mission? Well, it cost us $150 going to a supermarket in Cocoa Beach. We bought a vacuum cleaner and we vacuumed the Titan probe. And by doing that, we rescued the mission.
That is amazing. I'm really glad that I asked you this question. So we are coming close to concluding our today's webinar. I have one more question, but before I go to my final question, I'd like to ask you if there's something else you want to tell us, anything you want to share with us, anything you want to add to this presentation.
Well, just a wish that lots of girls and boys might study astronomy, physics, or whatever is needed, space engineering. Do it. It's fascinating. It's wonderful. And sometimes you even get very good salaries. So you have nice compensations. Please do it. It's the most wonderful job in the world.
And I would like to say that Marcello Coradini, it's an honor to be the chair of our council, the International Council of CSEO, and he has been instrumental in giving us the vision and or the energy to take on the next project and the next project to grow this organization, but also to send this message to the world, because this now is not broadcasted only in Cyprus, but it's broadcasted around the world. And the message is to everybody to embrace solar system exploration, because the future is all about space, especially in the next decades. We see humanity going from governmental agencies into non-governmental organizations and the industry going out there into solar system exploration.
Absolutely. Absolutely. I'm all with you in that.
And I'm going to go to my final question. We live through difficult times. We had the pandemic. We see the destruction of humankind on our own planet over mining the resources, the gases that we emit in our atmosphere, and a lot of people see things with doom and gloom. What is your message? What is your message for the future towards humanity?
Well, the message is that we have to handle our planet with care. We haven't done it until now. We have been playing with uncontrolled witchcraft, and now we're paying the consequences of that. And so the lesson is we gotta respect the place where we live, because otherwise that place, that planet will take a revenge. And whatever we do to the planet in 1 million years will regenerate itself, and it will come back beautiful or even more beautiful than before, but without human beings. So we gotta be careful.
Thank you. That was a most enlightening conversation. I hope you all enjoyed Marcello's insight in space exploration and the future of humanity, and how humans might actually look in the future, because that's how we started this presentation. Thank you for being with us.
Thank you for inviting me. It's been a pleasure and a honor.
Thank you, Marcello. And let me say at this point that please tune in back with us on the 23rd and on the 8th next month, because in the next 2 episodes we have Karen McBride regarding the exploration of Mars and John Rummel regarding the existence of solar, excuse me, I lost my words here, regarding SETI, which is the search for extraterrestrial intelligence, whether we are alone or whether there's life, intelligent life out there. Thank you. Thank you for watching us. Thank you, Marcello, and we'll be with you again soon. Goodbye.
Goodbye.